Welcome back. In this particular video, we're going to look at two other laws. One of them is Charles' law, and the other one is Gay-Lussac's law. Now, if you remember during the introduction video where I summarized all the laws, I described Charles' law as volume is directly proportional to temperature. What does that mean? If you increase temperature or uh, you increase volume, and if you decrease temperature, you decrease volume. You can think of it the other way, like you can increase volume, you increase temperature. You decrease volume, you decrease temperature. Okay, just like how we had a condensed law for Boyle's law, we can also write one for Charles' law, which is V1 over T1 equals V2 over T2. Now, I always prefer to convert my temperatures to Kelvin simply because it just gets me into the idea of not knowing when to convert, when not to convert. So I always prefer to convert my temperatures to kelvins. Okay, so here volume is given in liters, so we do not have to convert it, whereas temperature is in Celsius. So 20 degrees Celsius is 273 plus 20, which is 293 Kelvin. So that's your T1. Okay, this is the volume at this temperature. So we know V1, we know T1, we know V2, we don't know T2. Okay, that's what we're asked to find. Okay, so this is T1 right here. So V1 is 6 liters, T1 is 293 Kelvin, V2 is 4 liter, and T2 is, let's just call it X. Okay, so X is, so if you do it, it's 4 times 293 divided by 6. So it's 195.3. Okay, so because we have decreased volume, right? Temperature should go down, right? This is in Kelvin, sorry. Right? We have reduced the volume from 6 liters to 4 liters, so our temperature should go down, and that's exactly what happened. We went from 293 Kelvin to 195.3 Kelvin. There you have it. And so this is the condensed version of Charles' law. And next one is Gay-Lussac's law, which relates pressure is directly proportional to temperature. That means if pressure goes up or if temperature goes up, pressure goes up. If temperature goes down, pressure goes down. Okay, so just like how we had it for Boyle's law and Charles' law, the condensed law is P1 over T1 equals P2 over T2. Again, you can leave it in pounds per inches squared, the pressure, or you can convert it to ADMs. I'm just going to leave it in pounds per inch squared, and I'm going to convert the degrees Celsius to Kelvin. So that would be 273 plus 27 is 300 Kelvin. Okay, so I know my temperature 1, I know my pressure 1. I do know my pressure 2, I don't know my temperature 2. Okay, so I know my P1, T1, and I know P2, I just don't know T2. So therefore, so we have T1. We know P1 is 30 pounds per inch squared, and we know P2, which is 90 pounds per inch squared, and we just need to know T2. So P1 is 30 over temperature is 300 Kelvin, okay, equals P2 is 90, and T2 is, let's call it X. So let's solve for X. What will be? So it'll be 90 times 300 divided by 30 So it's 900 Kelvin. Okay. So let's see if the relation makes sense. What have we done from pressure 1 to pressure 2? We've increased it 3 times. So our temperature should increase 3 times, which makes sense. We went from 300 Kelvin to 900 Kelvin. All right. So stay tuned. I got 2 more videos to record on the concept of gas laws, and that would be Avogadro's law and Dalton's law of partial pressure. Right. So stay tuned.